Kubernetes and GKE Part 26. This episode has 4 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain operators. Here's a strong way to approach it. A Kubernetes operator in Kubernetes is a custom controller that automates the deployment, management, and life cycle of complex applications using custom resources. CRD's core idea: an operator is like a smart automation bot that knows how to run and manage an application end-to-end inside Kubernetes. It combines CRDs, custom resource definitions, define new resource types, controller logic, automates what happens when those resources change. Why operators are used: Kubernetes can manage basic things like pods and deployments, but complex systems need extra logic. For example, databases, PostgreSQL, MySQL, Kafka clusters, Redis clusters, backup systems. These require setup plus configuration, scaling logic, failover handling, upgrades, recovery. Operators automate all of this core components of an operator. 1. Custom resource definition. CRD defines a new object type like database, Kafka cluster, backup job. 2. Custom resource. CR the actual instance, kind, database spec, engine, Postgres version 15.3. Controller. Operator logic. Watches CRs, takes actions to match desired state, continuously reconciles actual versus desired state. How it works. Reconciliation loop. 1. User creates a custom resource. 2. Operator detects the change. 3. Operator checks current cluster state. 4. If mismatch, takes corrective actions. 5. Keeps reconciling continuously. Example flow. User YAML. Database CR. Operator. Controller. Creates stateful set plus service plus storage, manages backup, scaling, failover. Real-world example: PostgreSQL operator. When you create kind Postgres cluster, the operator automatically creates stateful set, configures storage, PV or PVC, sets up replication, handles failover, manages backups, performs upgrades. Operator versus controller. Feature: controller. Operator scope: basic resource management, full application life cycle, complexity low, high uses CRDs optional. Required example: deployment controller, DB. Operator. Simple analogy: think of Kubernetes equals factory, CRDs equals new product types. Operator equals intelligent robot engineer who knows how to build and maintain that product automatically. Benefits of operators: automates complex application management, reduces manual DevOps effort, enables self-healing systems, handles upgrades and backups automatically, provides Kubernetes native automation. Use cases: databases, Postgres, MySQL, MongoDB, messaging systems, Kafka, RabbitMQ, monitoring systems, backup and disaster recovery tools. Limitations: complex to develop, requires deep Kubernetes knowledge, debugging can be harder, overhead for simple applications. Interview ready. Definition: a Kubernetes operator is a custom controller that extends the Kubernetes API using CRDs and implements application-specific automation logic to manage the full life cycle of complex applications, including deployment, scaling, upgrades, and recovery, using a continuous reconciliation loop. Nice. Let's continue. Question 2. What is customize? Here's a strong way to approach it. Kustomize is a Kubernetes native configuration management tool used to customize YAML manifests without templating in Kubernetes. It is built directly into Kubectl. As Kubectl apply K-core idea, Kustomize lets you reuse and modify Kubernetes YAML files for different environments, dev, staging, prod, without copying or templating. Instead of editing files manually or using templates like Helm, you apply patches and overlays. Why Kustomize is used in real-world Kubernetes setups. You have multiple environments. Each environment needs small differences. Replicas, image tags, config values. Without Kustomize, you duplicate YAML files, hard to maintain. With Kustomize, one base YAML plus environment-specific overlays. How Kustomize works: Kustomize uses a base plus overlay model. 1. Base common Kubernetes manifests. 2. Overlays environment-specific customizations. Example: structure, myapp or base or deployment, YAML service, YAML customization, YAML overlays or dev or staging or prod or base customization, YAML resources, deployment, YAML service, YAML dev overlay. Example: resources or base patches, path, replica patch, YAML patch. Example: API version, apps or v1 kind, deployment metadata, name, myapp spec, replicas. 2. Apply configuration kubectl. Apply K overlays or dev key features of customize. 1. No templating. Unlike Helm, no variables or templates. Uses plain YAML. 2. Environment overlays. Dev, staging, prod configs easily separated. 3. Patching support. Modify only specific fields, replicas, image, NVVARs. 4. Built into kubectl. Kubectl. Apply K customize versus Helm feature. Customize. Helm approach. Declarative patches. Templating. Complexity low, medium, high. Learning curve easy, moderate. Flexibility limited, very high. Built into kubectl. Yes, no. Simple analogy. Think of base YAML equals master blueprint of a house. Customize overlays equals modifications for different houses. Dev house small size, prod house large. Production ready version. When to use. Customize simple to medium complexity deployments. Environment based configuration changes. Teams preferring pure YAML. No templating. Native Kubernetes workflows. Limitations. No advanced logic, loops, conditions. Less powerful than Helm for complex apps. Harder for large reusable application packages. Interview ready definition. Customize is a Kubernetes native configuration management tool that allows users to customize and manage Kubernetes manifests using a base and overlay approach with patches, enabling environment-specific configurations without templating and integrated directly into kubectl. Great. Moving on. Question 3. What is pod disruption budget? Here's a strong way to approach it. A pod disruption budget, PDB, in Kubernetes is a policy that defines how many pods of an application can be voluntarily disrupted at a time while maintaining availability. Core idea: a PDB ensures that a minimum number or percentage of pods are always running during planned disruptions. It protects applications from voluntary downtime, not failures. What disruption means? PDB only applies to voluntary disruptions, such as node maintenance, draining a node, cluster upgrade, scaling down nodes, manual eviction, kubectl drain. It does not protect against node crashes, hardware failure, unexpected outages. Why PDB is used? It helps to maintain application availability during maintenance, prevent too many pods from going down at once, ensure high availability for critical services, control safe rolling updates and cluster operations. How it works: 1. You define a PDB for a set of pods via label selector. 2. Kubernetes checks the PDB before evicting pods. 3. If eviction violates the budget, eviction is blocked. Key fields in PDB: 1. Min available, minimum number of pods that must remain running. 2. Max unavailable, maximum number of pods that can be unavailable. Example: PDB, min available, API version, policy or v1 kind. Pod disruption budget metadata, name, my app, PDB spec, min available. 2. Selector. The exact commands and code are in the written question bank. Alright, next question. Question 4. Explain resource requests. Here's a strong way to approach it. Resource requests in Kubernetes define the minimum amount of CPU and memory a container is guaranteed to get. Core idea: a resource request is what a container needs to run properly. It is used by the Kubernetes scheduler to decide which node can host the pod. Why resource requests are important? They help Kubernetes schedule pods on appropriate nodes, avoid overloading nodes, ensure stable performance, prevent resource starvation without requests. Pods may be scheduled anywhere. Risk of CPU or memory contention increases. How it works: 1. You define CPU or memory requests in pod spec. 2. Scheduler checks available node capacity. 3. Pod is placed only where requested resources fit. 4. Container gets at least that amount guaranteed. Example: YAML API version, v1 kind. Pod metadata, name, my app spec, containers, name, app. The exact commands and code are in the written question bank. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.